a greater than 1 and x is greater than 1, satisfy log a of log a of log a2 plus log a24 minus 128 equals 128, and log a of log ax equals 256. Find the remainder when x is divided by 1000. The first equation looks very tricky and complicated, especially because there are so many times the word log appears. Let's try to get that word out of the equation. First, let's remove the first log a. We can look at everything after it, and that's equal to a to the 128. So log a of log a2 plus log a24 minus 128 equals a to the 128. Now we can add 128 to both sides. We have log a of log a2 plus log a24 equals 128 plus a to the 128. Now we can combine the log a2 and 24 because log of, suppose m plus log n equals log of m times n, no matter what base this log is written in. So we can do log a of 24 log a2 equals 128 plus a to the 128. And finally, we can get rid of the first log again. We know that 24 log a2, that's equal to log a of 2 to the 24th equals a to the power of 128 plus a to the 128. And this is equal to a to the 128 times a to the 128. Now we can remove log again, so we're just left with 2 to the 24th equals a to the power of a to the 128 times a to the 128. This can be written as a to the 128 to the power of a to the 128. So now we have the word log completely removed from the first equation. We just have 2 to the 24th is equal to a to the 128 to the power of a to the 128. And to solve this equation for a to the 128, let's call that value 2 to the n. So now, what happens when we do this? We have 2 to the n to the power of 2 to the n equals 2 to the 24. And so we have 2 to the power of n times 2 to the n equals 2 to the 24. And so n times 2 to the n is equal to 24. 24 is equal to 3 times 8, and that's 3 times 2 cubed. So n is equal to 3. So that means a to the 128 is equal to 2 cubed. But the question doesn't ask for the value of a to the 128. It asks for the value of x, which is some number in terms of a. Log a of log ax equals 256. So x is equal to a to the 256. We want to find the remainder when a to the 256 is divided by 1000, not a to the 128. In order to find the value of x, which is equal to a to the 256, we need to first find a, given that a to the 128 is equal to 2 cubed. So let a equal 2 to the m. And let's find the value of a that satisfies a to the 128 is equal to 2 cubed. And then let's do a to the 256. So rewriting this equation with a equals 2 to the m, we have 2 to the m to the power of 2 to the 128m equals 2 cubed. And so 2 to the power of m times 2 to the 128m equals 2 cubed. And now removing the 2 to the power of everything, we get m times 2 to the 128m equals 3. And solving this equation is not hard. We just multiply the whole thing by 128. So we get 128m times 2 to the 128m is equal to 3 times 128, which is 384. And that's equal to 3 times 2 to the 7th, which is 6 times 2 to the 6th. So 128m is equal to 6, as you can see here. We have m equals 6 over 128, which is just 3 over 64. So a to the 256 is just 2 to the m, which is 2 to the power of 3 over 64, to the power of 2 to the power of 256m. 256 times 3 over 64 is 768 over 64, which is 12. So 2 to the 364, 3 over 64, to the power of 2 to the 12th. And that's equal to 2 to the power of 2 to the 12th times 3 over 64. And that's equal to 2 to the power of 3 times 2 to the 12th over 2 to the 6th. which is equal to 2 to the power of 3 times 2 to the 6th, and that's equal to 2 to the 192. So we need to find the remainder when 2 to the 192 is divided by 1,000. In order to find the remainder when 2 to the 192 is divided by 1,000, we need to consider its remainders when it is divided by 8 and 125. So first, the remainder when 2 to the 192 is divided by 8 is obviously 0. So we can write 2 to the 192 is congruent to 0 mod 8. And for the remainder when 2 to the 192 is divided by 125, well, 2 to the 192 can be written as 2 to the 12th to the power of 16. And you know that 2 to the 12th is equal to 4096. So this can be written as 96 to the 16 mod 125. And we can keep squaring 96 4 times until we get the remainder when 2 to the 192 is divided by 125. So first, 96 squared is 9216. And 9216 is congruent to 91 mod 125. So we can write 91 to the 8th power. And then 91 squared is 8281, which is congruent to 31 mod 125. So that's 31 to the 4th. And 31 squared is 961, which is congruent to minus 39, or 86, whichever one. I'll just use minus 39 mod 125. And minus 39 squared is the same as 39 squared, which is 1521. And that's congruent to 21 mod 125. So we know that 2 to the 192 is congruent to 0 mod 8, and it's also congruent to 21 mod 125. So to solve this system of linear congruences, we need to list out all the positive integers less than 1,000 that are congruent to 21 mod 125. And by the Chinese remainder theorem, there's only going to be one of those that is congruent to 0 mod 8. So we have 21, 126, wait, not 126, 146, 271, 396, 521, 646, 771, and 896. 21 is not a multiple of 8. Neither is 146, 271, or 396, or even 521, 646, or 771. The only valid answer is 896. And that is the remainder when x is divided by 1,000. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.